Simplify the square root of 4a squared. We can use the product rule to separate this as a product of radicals, writing it as the square root of 4 times the square root of a squared. The square root of 4 is just 2. The square root of a squared is a little bit more complicated. When we want to know the square root of something, we're asking what can we square to get that quantity. And so if we ask what can we square to get a squared, the answer that probably comes to mind is a. Taking the square root of something and squaring something are kind of like reverse operations, and so we end up with a. But there's a little bit of a problem. I am going to box this answer in. This answer is true. This answer is correct if a is greater than or equal to 0. But there is a problem if a is negative. There's a problem if a is less than 0. And I'm going to show you that problem. Let's let a be negative 5, for example. Let's evaluate the square root of 4a squared if a is negative 5, and let's evaluate 2a and see what happens. If we substitute in negative 5 in this first one, we have 4 times negative 5 squared. Negative 5 squared is positive 25, so we've got 4 times 25. 4 times 25 we know is 100, so we've got the square root of 100, which is 10. However, if we just go to 2a and we substitute in negative 5 there, we have 2 times negative 5, and 2 times negative 5 is negative 10, and these two things are not equal. So we have an example where the square root of 4a squared is not equal to 2a. The reason that this happens is because when we have this square root symbol and we're taking the square root of a quantity, there is a convention that we're looking for the positive square root. Technically, there are two numbers that we could square to get 100, positive 10 or negative 10. But this symbol tells us we want the positive square root, positive 10. The problem with doing a problem like this when there is a variable in it and we just pull the variable out is that that variable could be negative. In this case, if it's negative 5, 2 times negative 5 is negative 10, so we have a negative quantity when we really wanted a positive quantity. There are two ways to deal with this. The first thing we can do is just assume all variables are non-negative. So if none of your variables are negative, then you're going to end up with a positive quantity anyways, which matches what we want. So that's one way to deal with this. The other way to deal with this is to use absolute value symbols. So in this problem, when we have the square root of 4a squared, we could write this as 2 times the absolute value of a. We know that absolute value signs will give us non-negative answers in the same way that a square root sign will give us non-negative answers. So this is another way to deal with it. There are certain instructors and certain textbooks and certain courses where if you're asked to find the square root of 4a squared, the answer is going to be 2 times the absolute value of a. In my class, I generally don't deal with that. I just say that we're going to assume that the variables aren't negative, so we don't have to deal with those absolute values. I do go through this explanation so that students are aware of the issue, but just to make things a little bit easier, I always deal with problems where we just assume the variables aren't negative and we don't have any problems.